Convert to a logarithmic equation. 5 to the 2x equals 100. First, let's review the general form of a logarithmic equation. And it's going to take me just a little bit to write this out because I want to use different colors to specify log base b of, I'll use orange for log base b of x, and then equals, I would like to use the color blue for what it is equivalent to. Okay, now this is the exponent. And you may have heard this idea that a logarithm is an exponent, and this is what it means. Log base b of x equals some exponent. And it doesn't, I know it doesn't look like an exponent here, but when I turn this back into an exponential equation, you'll see that this is actually an exponent. And then b, that's in this purple, is the base. And then log base b of, this is what you're taking the logarithm of. Okay, what the exponential is equivalent to. So I like to draw some arrows here. The base raised to, let's use a different color. The base raised to the exponent equals this value. Okay, so if I were to rewrite this, I would say b raised to the y power equals this x. Okay, I should point out here that the y and the x are just placeholders. They're for the general form. So, for example, in our specific example, our exponent has a 2x. It has no y in it. So I'm going to color code this. This is our exponent. So I'm going to write that down right now. I'm going to say equals our exponent. We're halfway to writing this exponential as a logarithmic. And you can always do that when you're faced with these problems. Okay, base, that's the 5. So I'll circle that. And then I'll write log of base b. So I'm going to write all of that in purple. Log of base 5 is our base. And then 100 is our x. So log base 5 of 100 equals 2x. And that's how you would pronounce or say that. Log base 5 of 100 equals 2x. So notice I said, hey, this logarithm is an exponent. It equals this quantity, y in our general case, and we can see if it's written in exponential form, then it is an exponent. And that's why people say logarithms are exponents. Okay, the next example, convert to an exponential equation. Log base 3 of x plus 20 equals 10. We're going to just go with this example up here, this general form, and I'm just going to draw the arrows and say base 3 raised to the exponent of 10 equals x plus 20. So we're just going to write that right out. 3 raised to the 10th power equals all of x plus 20. And these examples in particular are specifically designed to show that this process works no matter what the base is, no matter what you're evaluating or taking the logarithm of, or what the exponent is. The process works, and that's why we have this x plus 20. It looks kind of nasty here, all these things. It's not just something, 2 to the third equals 8. But we want to show that this process works no matter what values are written here. All right, so we've converted in both directions.